Hello, and welcome to the second installment of Solid Shapes and 3D Drawings. We're going to talk about several things today. One of the things we're going to talk about is viewing isometric figures. Okay, remember the isometric figure is a 3D figure that we're viewing in a two-dimensional plane. Now, if we look at this isometric figure, we can see that it's 3D. We can see all these different types of faces because we're kind of looking at it from the top right? We're kind of on top of it, but to the right, so that we can see a lot of different types of faces. Now, if we were just going to view it directly from one side, so not at an angle, then we would get a different perspective of that drawing. Now, what we call those are orthographic drawings, and what they are actually two-dimensional drawings. So, for example, if we were to look at the top view of this figure, all right, if we were just to be right on top, viewing it from a helicopter, and all we could see is the top, all we would see are these two rectangles right here, okay, and this line right here. So it would look like they were sitting right next to each other, okay, so that would be the top view. If we were looking at it from the right, all we would see is this tiny little rectangle here on the top, and then this big long rectangle on the bottom. And they would look like they were right on top of each other. So that would be the right view. If we were looking at it from the left, all right, this one takes a little bit of an imagination, right, because it's not actually given to us, but we know that we're looking at rectangles, right? We know that this is kind of a short rectangle and this is a long rectangle. So if we were looking at it from the left, that's what we would see, a long rectangle and a short rectangle. Now, when we're viewing isometric figures, we want to look at it from 6 different perspectives. Okay, so make sure whenever we're looking at it that you look at it from those 6 ways. Okay, we want to look at it from the left and the right, the front and the back, and then the top and the bottom. So, for example, if I'm looking at the left view of this figure right here, all right, I know I'm looking at rectangles. Okay, so I have this kind of tall rectangle, and if I was looking at it from the left, this tall rectangle is blocking my view from the bottom part of this figure. So all I would see then is a short little rectangle there on the top. So a left view would give me this short little rectangle and then a long rectangle. The right view, right, if I looked at this right view, it's just one rectangle. The front view, okay, I'm looking left to right, would be just like this. I mean, the front view, that's kind of the perspective that we have is the front, right? So that's going to be the front view. Now, if I looked at it from the back, right, we're still looking left to right, so it would be the same except you would just flip it, right? The back, then we would look at this side first, and then this side would be on the right. The top view would be this, narrow little rectangle, and then we get a little longer rectangle, and then an even longer one. So if we look here, that's kind of what we see, right? Not so long, a little longer, the longest. Okay, and then the bottom view is just going to be one solid rectangle. Okay, now these are important because what we're going to do is be finding surface area. So it's really important whenever we find the surface area. Okay, remember area is just the amount of space that the amount of cubes that make up a two-dimensional figure. Okay, surface area is going to be the amount of cubes that take up the outside part of a three-dimensional figure. Okay, so this is where knowing your faces becomes really important because when you're finding the surface area, what you're going to do is just find the area of each face, and then you're going to add up all of those numbers for the total surface area. Okay, so let's do that here. The front then, right, we're looking at it from this perspective, so our front is going to be this rectangle right here. So our length is going to be 10, and our width right here is going to be 2. So we have 10 times 2, which is 20. Okay, the back is the exact same, right? 10 times 2, which is 20. If I look at the top, sorry, horrible drawer. If I look at the top here, my length is going to be 3 and my width is 2. So 2 times 3 is 6. Okay, and then the bottom is the exact same, right? 2 times 3 is 6. Now, if I look at the right figure, the right face, okay, I have a length of 10 and a width of 3. So 3 times 10 is going to be 30. And then the left view, right, this left face right here is going to be the same. 3 times 10 is 30. Okay, so then we're just going to add all of these up. 6 plus 6 is 12. Carry the 1. 3, 6, 7, 8, 9, 10, 11. So this is going to be 112 inches squared. We still say inches squared because we're talking about area. Now, finding the surface area, okay? This figure is composed of cubes that have a length of 1 inch on each side, okay? 1 inch on each side. 1, 1, 1, 1, 1. 1, 1, 1. How many faces does the three-dimensional figure have? Now, when we're talking about faces, we're just talking about the number of sides that it has, okay? So, not the number of cubes, okay? So, if we look at here, it has 1, 2, 3 that we can see, right? But it also has this left one, the back one, and the bottom one. So, it really has 6 faces, right? 3 that are visible and then 3 that are hidden, okay? When we're describing surface area in terms of the figure, okay, then we're just basically what you're doing is just telling me how you're going to find the surface area. So what you would say is you're going to find the area of each one of the 6 faces and then add them up. So that's what we're going to do here when we find the surface area of each figure. Okay, so let's start with the front. The front then we can count, right? 1, 2, 3, 4, 5, 6. It's 6 high, and then 1, 2, 3, and then 3 is our width. So we're going to take 6 times 3, which is 18. Okay, now we know the back is exactly the same. So we're going to take 6 times 3, which is 18. Now let's take the right and the left view. All right, so we're going to start with the right because that's the one we can see. If we count 1, 2, 3, 4, 5, 6, and then 2 across, so this is going to be 6 times 2, which is 12. Okay, we know that the left is the same, so 6 times 2 is 12. Now we're going to take the top and the bottom. So the top then, we have 2 as our length, and 1, 2, 3 is our width. So we're going to have 2 times 3, which is 6. And 2 times 3, which is 6. Okay, so now we're going to add up all of these numbers, okay? 8 and 8 is 16, 17, 18, 19, 20. 6 and 6 is 12, so that's 32. Carry your 3, 3, 4, 5, 6, 7. Oh, I drew my line wrong. 72 inches squared, right? Because we're talking about surface area still, so units are really important. Okay, the last thing that we're going to talk about is finding volume, okay? Volume is how much space the whole figure takes up. So that's basically for, if we're dealing with cubes that are 1 inch, 1 by 1, then it's basically how many cubes make up the whole figure. Now, we're not always going to deal with cubes that are 1 by 1. So our formula then is going to be length times width times height. Okay, so for example, our length here is 4. Our width is 2 and our height is 6, right? 1, 2, 3, 4, and then 1, 2, and then 1, 2, 3, 4, 5, 6. 4 times 2 times 6 is 48 cubic units, or units cubed. Okay, remember volume, we say cubed, not squared. So for this one, this is the same figure earlier, okay? We want to describe volume in terms of the figure. So again, you're just describing how you would find volume. Okay, so how you would find volume is you would just find out how many cubes make up this figure and then you would add them up. Or you would take length times width times height, which is what we're going to do right here. Okay, so our length then is going to be 3. Our width is going to be 2. And our height is going to be 1, 2, 3, 4, 5, 6. Okay, so we're going to say 3 times 2 times 6, which is 36 inches cubed. And that's how you find volume. And that is the end of Solid Shapes and 3D Figures Part 2.